fractions and whole numbers, multiplying fractions and mixed numbers. A whole pile of stuff. New stuff. Brand stinking. Have you ever seen it before?
No.
$10 says no. Never seen it before. This is
Not
adding fractions. You will not see me doing this. Because what does this mean?
Change your bottom.
Get the bottoms the same. You will not see me do this. Okay? Because today is not adding or subtracting fractions. Today's easier than that. The hard stuff with fractions is adding and subtracting because you have to get the same bottom denominators, right? Multiplying fractions is easy. Lemon squeezy. Alright? Alright. Now we got a few things we got to do this. I'm going to work this bad boy right here as we do the stuff. Okay? Is that alright? So here we go. Y'all ready to do the easy stuff? Y'all be going, man, this is so easy. Wish we would have done this before we did adding. You're bouncing us around there, dude. Steady. Steady. The numbers must be in fract form. They must be in fract form. Whether it's improper or not, you must have fraction form. If you look over to the sideboard over here, this first example, that, get over there, has a what? No. Mixed number. I cannot multiply this like it is because both of these need to be just fractions. Okay? So, what we got to change?
The whole number?
Change mixed number to, what did you call it a minute ago, Holden?
Improper.
And M, well, that's a pretty good trick there. You threw your voice way over there. You're going to be a good ventriloquist. Improper fract. Y'all remember how to change a mixed number to an improper fract?
31.
Like 3 1/4. Loopy.
Loop.
That's what I called it, right? Loopy loop. Loop times loop plus. Y'all remember that? Lex, you remember that? So, when we start working these problems, especially when we get to that sideboard, because I don't see any mixed numbers over here. Alright? We're going to have to change that mixed number into an improper because you cannot multiply fractions unless they're in fraction form only. Alright, Austin? You with me there? You with me? They've got to be fractions. So we might have to do some changing first. What if you have a whole number like this one times a fraction? Or like this one right here, a fraction times a whole number. This is not a fraction, it's a whole number. And to multiply fractions, we got to have them in fraction form. How do I change a whole number to a fraction? Nope.
You just put the same number underneath it.
Nope.
You make prime and cast for decimal when you make it.
Nope.
Loopy loop.
No.
Nope.
I know how to do
Oh, you are killing me.
Just add a bar.
Add 100 under.
Nope, not 100.
10?
Nope.
No place.
Changing a whole number.
No place value.
Hey, quit guessing. Quit guessing. We're not doing decimals. We're doing fractions. No, no more guessing, because y'all all messed up the video here. Answering a bunch of stuff and making us all look bad because you can't remember what a whole number is in fraction form. Change whole number to a fract by putting a 1 under it. Whole number 7 as a fraction is 7 over 1. I cannot believe you forgotted that. Jiminy stinking Christmas. That's right. Do you remember it now?
Yes.
A whole number in fraction form is just the number over 1. Don't forget the easiest part of this stuff. Good night, boy. I'm rocking. Alright, so we're going to get these things in fraction form. Okay? There's a shortcut. We're not doing a shortcut yet, so leave yourself some space. Go to number 3. We're going to come back to the shortcut after I learn you how to do it without the shortcut.
Uh-oh.
Okay? Step 3. When you have fraction times a fraction, you've changed stuff if it needs to be changed, and you have nothing but a fraction and a fraction, and you're multiplying. Here we go. Look how easy this is. What does that say, Saga?
Top times top.
What am I talking about?
Numerator times the numerator.
Numerator times numerator. I always do this. 2 times 3?
6.
6. Boy, this multiplying fraction stuff's hard. What do you think 4 is going to be?
Something to do with the bottom.
Yeah, but put it in plain English.
Bottom times bottom.
Bottom times bottom. We'll put that in there because mathematicians want us to know those words. Bottom times bottom, which is denom times denom. So I do this right here. 5 times 7. Man, this stuff's hard.
35.
35.
Simplify.
What do you think step 5 is?
Simplify.
When we're dealing with fractions, at the very end, we always make sure it is simplified. Kill. Is that simplified? Will anything divide out of both of them?
6.
No. No.
Well, it's amazing. One person says yes, and everybody jumps on the wagon. Yeah, baby, sure can. Woo! Instead of thinking, one person should say yes, and then everybody else went, no! Don't jump on the bandwagon just because everybody else said yes. What do you think, Mr. Taylor? No, nothing will divide out of a 6 and also a 35. You've multiplied 2 fractions together. Now, wasn't that a lot easier than adding and subtracting fractions where you have to get the same denominator bottom? Right? Man, that's so much easier. We still got a shortcut, don't we?
Yes.
All right, we'll keep going. All right, here we go. Are these both already fractions?
Yes.
Top to top.
14.
14. Bottom to bottom. Huh?
72.
72.
Simplify.
Simplify. Divide by.
2.
2 and 2.
36. And 7.
7.
36.
36. How you like this multiplying fraction?
Easy.
Bam.
6 over 35 and 7 over 36.
Oh, they both go down. That's funny.
6 after 1. 6, 7, 35, 32. The numbers are right out.
No idea what she's talking about.
The
Someone's getting me off task is what I'm thinking. We can shortcut now. Okay? Don't erase, but rewrite this problem again right beside it or underneath it. Shortcut. I can shortcut this one. I'm going to teach you to shortcut. What does it say, Watson?
Cross simplify.
Cross simplify if possible. Cross simplify if possible, Sam. You writing this down on your shortcut. That's what I was thinking. Cross simplify if possible. Now y'all going, well, that's good, but I don't know what that means. Well, here, let me explain what that means. Okay? Div,
She said it was a yes.
divide, something out of a top. Sagi, you were drawing the simple shortcut?
Oh.
Like a 2 turning into a 1.
Divide something out of a top and out of a bottom before you molt. I'll explain that. If it's still confusing, I'm going to show you, and you're going to be going, oh, this is awesome stuff. Technically, what we're going to be doing is we're going to be simplifying before we multiply, instead of waiting to the end and simplifying. Okay? Got it? Watch this. Now, we already did this. We already know what the right answer is. But let's see if we can make it an easier problem by cross simplifying, meaning a top one and a bottom one. Do you see a number that will divide out of one of the tops and one of the bottoms? Holden.
2 and 8 supposed to be a
No. I said, what will divide out of a
2.
top and a bottom?
2.
A 2 will divide out of the 2
And the 8.
and the 8. So watch. Divide by 2. Divide by 2.
1.
No, don't get ahead. Because I got some people looking out the window and not watching up here. I mean, if y'all don't want to learn the shortcut, this is going to help you unbelievably up the hill and then in algebra and algebra 2. If you don't believe me, ask the lady right there and ask the boy right there back there. Simplifying before you do the work. Oh, wait till you get a big old algebra problem up there and you simplify the top and the bottom before you do the multiplying. Right, Mr. Snow? Mm-hmm. All right, what's 2 divided by 2? 1. What's 8 divided by 2? 4. Now, top times top.
7. 36.
Bottom times bottom.
36.
Is that what we got a minute ago? We don't have to simplify our answer now because we already simplified. Always check. Will 7 over 36 simplify again?
No.
So that's the shortcut. Now let's see if that helps us speed up. All right, Sam? Let's go to the next example. 3/8 times whole 10.
1 on the bottom.
Of who?
10.
Oh, okay. So I can do this right here. Right?
Yep, show.
Because that's step 1. I must be in fraction form. One of them wasn't in fraction form. So I make him a fraction over 1. All right? Can we shortcut this one?
Yes.
Will something divide out of one of the tops and one of the bottoms?
Yes.
The 10 and the 8. What will divide out of a 10 and an 8?
2.
2. So let's do that again. Divide by 2 there. Divide by 2. What's this number?
5.
5. What's this number?
4.
4. We okay?
15.
Top time top.
15.
Bottom time bottom. 4. Now I'm not circling that. How come for a come? Now Ellie, how come for a come? Why am I not circling that as my answer?
Improper.
It's improper.
Yeah. I never leave a fraction top heavy, improper, right?
You have to still simplify.
Simplify, not divide by, but bottom into
Top.
top. How many 4s can get close to 15?
3.
Big 3. Do you have any leftovers?
3.
How many leftovers?
3.
Because 3 times 4 is 12. There's 3 leftovers from the
15.
15.
Dino.
Bingo.
Right, Sam? You with me, bub? I know you're all yawning awful big back there. I lose your legs? All right. Because you about to go sleep leaning on your elbow there. 3 times 2 9s. You got a problem with this one?
Yes.
What's the problem with it?
Put a 1 under the whole.
They're not fractions.
Yes.
That's the problem.
Yes.
How do you solve the problem?
Put a 1 under the
You can
whole.
divide them both
There you
by
go.
1.
All right. 6 over 9, right?
Right.
Right?
Divide by 3.
Top time top, bottom time bottom. Divide by 3, divide by 3.
1, 3.
2 thirds. Now, could I have simplified first?
Yes.
Divide by,
3.
divide by
3.
1.
1,
3.
3. 1 times 2.
2.
1 times 3.
3.
Bingo.
Works with the shortcut, works without the shortcut. So do you have to rely on the shortcut? No, you can still get the right answer even if you don't do the shortcut. You just got to do some simplifying at the end. Because the shortcut is simplifying before we get to the end. Everybody okay? Okay, Tanana, would you switch places with Brother Watson in just a moment? All right, because we're about one more and then we're going to go to Southboard. What's wrong with this bad boy, Alyssa? Alyssa! Alyssa.
It's using letters instead of fractions.
Uh-oh, what's this called?
Algebra.
It's called algebra. That's what it's called. But we're not scared of algebra, right? This algebra just means they threw letters in there. Now, what are they telling us, Alyssa?
The sentence before it tells you what the letters represent.
Okay, tell us.
X equals 4, and Y equals 2 thirds, and Z equals 1/4.
Okay. Now, what's that other thing?
It says that it's multiplying all 3,
How do you know that?
because they're all slammed together.
They're all slammed together. If they're all slammed together, that's always meant multiplying. So technically, this is X times Y times Z. 3 things are getting multiplied. Is that okay?
Yeah.
All right, what is the X?
4.
4
2 thirds.
times
2 thirds.
2 thirds times
1/4.
1/4. Now, can we multiply?
No, not yet.
Why far come?
Fractions.
They're not all fractions.
So 1 under the big 4.
1, there we go. Now they're all fractions.
Now.
Okay? I'm going to show you without the shortcut, and I'm going to show you with the shortcut. 4 times 2
8.
times 1.
8.
Good. 1 times 3
3.
times 4.
12.
12. Divide by.
4.
4. 4.
2.
2.
6.
Thirds. Bam.
That was easy.
Pretty easy, isn't it? Okay? Now, let me take away my multiply arrow there. And let's see if it'll work by simplifying first.
4 and 4.
Okay? So, do you see something from the top and from the bottom I can simplify? Who? No, hold on. You've been answering too many things. You're just too smart. Sam, do you see a top and a bottom here that will divide out?
Yes.
Okay, what?
2 times 4.
2 times 4? No, we're trying to divide something out, and you're yelling times at me, dude.
2.
The 2? The 2
And the 4.
and the 4. He is correct. So, what can divide out of a 2 and a 4? I did it. Sam.
Oh. Divided by 2.
Oh, 2 will divide by 2. 4 will divide by 2. So, what's 2 divided by 2? 1. What's 4 divided by 2? 2. Okay? 4 times 1.
4.
Times 1. 4. 1 times 3.
3.
Times 2. 6. Divide by 2. What do you get?
2/3.
Voila. Now, Miss Taylor. Miss Taylor, could I have simplified a different way?
Yes.
What?
The 4 and 4.
All right. Miss Taylor says divide this 4 and this bottom 4 by what?
4.
By 4. Okay, let's see what happens when we do that. Peter, what?
1.
Peter, what?
1.
1 times 2.
2.
Time 1.
2.
1 times 3.
3.
Time 1.
3.
Voila. So we did this problem 3 different ways and still came up with the same answer. Is that okay?
Yes, sir.
You don't have to simplify. You can just bam, 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 and then simplify at the end. Or you can simplify like Sam did, and it works. You can simplify like Taylor did, and it works. So don't get all hung up, oh, I did it different than he did. So what? If you do the mathematics correct, you'll come up with the same answer. Right?
Right.
All right, let's come over here. Sleep floppy. All right, here we go. Read it to us, Alex. Good job.
If R equals
Nope, wrong one.
6 1/5 times 1/2.
All right, here we go. What's wrong with it?
Mixed number.
Mixed number. How do I get rid of this mixed number? Loopy loop. Bam, bam. How much?
36.
Bullcorn.
30.
Bullcorn.
25.
Bullcorn.
31.
Thank you very much. 6 times 5 is 30 plus the 1. 31 back over 5 times a half. Everybody okay? Shortcut.
No.
What do you mean no?
1 times
It
5.
can't be done. Oh, yes.
1 and 5.
The only problem is it doesn't change my problem.
Easier.
Reason you're correct. I could divide a 1 out of both of them, but it doesn't change anything. Okay? That's a good try.
There's not any.
Oh, so some problems you can't. Some problems you can't. Some problems you can't. Some problems you can't.
You can't.
Shortcut.
Thank you very much. Shortcut. You gotta finish the sentence, ding dong. Nah. So let's just go top times top.
1.
10.
Bingo.
No, I'm not bingoing that.
It's
It's improper. Divide the bottom into how many 10s can make 30?
3.
Big 3. Any leftovers? 1 left over.
10.
Over the 10.
Bingo.
Now we can bingo. Are we smooth on this now? Is it going pretty good? 4 and 1 6 times 9 tenths.
Loopy loop.
What we got here? Loopy loop.
25.
25 sixes. All right. Can I do it regular? I can simplify. Now, would it help me to shortcut this one first? I'm about to get some gigantic numbers.
Yes.
25 times 9 is about to give us a big number, isn't it? And the bottom number is going to be 60. And so I'll be trying to get 60 divided into a big number. How about we simplify it first? What do you think?
Yeah.
Okay. So, wait, hold on. Tuck, what do you want to do?
Divide 25 and 10 by 5.
I like that. So she's going to divide by 5 here, Divide by 5. What do we get?
5,
5
2,
and 2. Alec.
69.
Oh, he wants to simplify some more shortcut. The 6 and the 9. Divide by 3. Sometimes you can do it of all of them. What do we get? 2 and a 3. Now, let's go 5 times 3.
15.
2 times 2. 4. Now that's a lot easier to work here than that 25 times 9 over 60, right? Ooh, man, that'd been big. How many 4s make 15? 3. How many leftovers?
3.
It's over there.
It's over there, yeah.
My land, that's exactly the same 15 fourths as over there. The only thing is we had a whole different problem right here. Wow. Good job. Now class, I'm going to tell you what the most common mistake students make on this stuff right here. And I'm not telling you to get it in your head, I'm telling you so don't ever do it. Does anywhere in our stuff and what we've done today where I said multiply the whole number times the whole number and the fraction times the fraction? Have I ever said that today? No. I said you cannot multiply these unless they're in fraction form. So you've got to change mixed numbers, turn them into a fraction before you can work it. Don't be doing no whole numbers times whole numbers. Wears me out. Do this one right here. Come on, Justin.
If R equals 1 and 2/3, S equals 2 1/5, and T equals 3/4.
That's it. What's our problem?
1 and 2.
No. Say RS.
RS.
RS. What do you mean by RS?
R equals
No. What do you mean by RS?
1 and 2/3.
No, what do you mean by RS? What math is happening?
Multiply.
There you go. That's what I want to hear. I want to hear you say R times S. Now let's go, Bubba. You're doing good.
1 and 2/3.
1 and 2/3.
And 2 and 1/5.
2 and 1/5. Now here's what students do. They go 1 times 2 is 2, and we got 2 15ths. Here's our answer. Bull corn. Nowhere up there did I say multiply the whole numbers together, then multiply the fraction together, did I? So why do students do that to me every year?
Because they make.
Because they're ding-dong head. Because they ding-dong head. No, you cannot do that. You cannot do that. No, you cannot do that. We got to change. Loopy-loop. Here we go. 5 over 3 times 11 over 5. What do you think, Jasmine? Regular or can we shortcut? How can we shortcut? No. 3 won't make 11. 5 and 5. How about divide by 5? Divide by 5. What do we get? 1. 1. 1 times 11.
11,
3 times 1.
3.
There we go.
No.
How many 3s make 11?
3,
3 3s make 9, leaving us how many leftovers?
2,
2 leftovers.